All right, this video is going to start by grading 12-3. It's out of 57 points. For 26, you're already in moles, so you just have to use the mole ratio. So 0.172 moles is a half point. Multiply by the mole ratio of 2 to 1, you get 0.344 moles of NaBr. Half point for answer, half point for sig figs, half point for unit, half point for substance. You should be telling me why you're marking off. If it's sig figs, it's minus a half, right? Units, just a half. Substance, just a half, right? Number 27, you start with 4.9 times 10 to the 25th molecules of O2, multiply by 1 mole over Avogadro's number times the mole ratio, 2 to 1, and then Avogadro's number. You can see that Avogadro's number cancels in the denominator and the numerator, so I'm really just taking 4.9 times 2. So the answer is 9.8 times 10 to the 25th formula units of CaO, right? Assuming that you keep that power of 10. Number 28, you start with 35.00 grams of CH4, divide by 16.0 times 2 over 1 for the mole ratio. Here I have molar volume. I'm going to have 98.0 liters of O2. For 29, I start with my particles, 1.33 times 10 to the 24th atoms, divided by Avogadro's number. 2 to 3 for the mole ratio. Once again, Avogadro's number in the numerator. So I get 8.87 times 10 to the 23rd atoms of Al. I could have easily, right, canceled this one and this one. So it's just 1.33 times 10 to the 24th times 2 divided by 3 in my calculator. For 30, I have here 531.8 divided by 253.8. times 2 over 1 times Avogadro's number gives you 2.52 times 10 to the 24th atoms of Ag. If you could, please write how many you missed at the bottom. Now we're moving on to the next page. 16.3 moles of N2 times 22.4 liters of N2 equals 365 liters of N2. 32, you start with liters and you're going to go to grams, so then you have to first use molar volume. 1 mole over 22.4 liters. Mole ratio is 4 to 3. Molar mass is 27.0. It's 8.04 grams of Al. For 33, you start with your given of 92.45 grams, divide by the molar mass of Na times 1 over 4 for the mole ratio. Molar volume is 22.4 liters. You get 22.5 liters of O2. For 34, you are going to start with your given 20.0 grams of FeBr2 divided by 215.6 grams of FeBr2. 1 over 1, and then you get 22.4 liters of Br2, which gives you 2.08 liters of Br2. For 35, you have 35.4 grams of Zn divided by 65.4. Mole ratio is 1 to 1 times molar volume, 22.4 liters over 1 mole gives you 12.1 liters of H2. For the last one here on 36, 17.7 divided by 65.4, 1 over 1. Times 6.02 times 10 to the 23rd formula units of ZnCl2, which gives you 1.63 times 10 to the 23 formula units of ZnCl2. Write how many you missed at the bottom, and then you should write a score out of 57 points. Keep that for the next time that I see you. And then we're going to move on to talking about the pre-lab. So the pre-lab looks like this. It says decomposition of sodium chlorate pre-lab. In this pre-lab, you want to make sure that you read the lab. We talked about last time that it's important that you are reading the entire lab to make sure you see where you're trying to end with how to look at stoichiometry, okay, and find the decomposition of sodium chlorate, okay? So you're going to tear off this first page because this is what you're going to turn in when I see you next time. What you're going to do is make sure you read this, okay? I have done a great job here of putting in bold what the purpose is. It would be everything that's in bold here, all right? Now, what's going to happen, right, is we have this background of sodium chlorate, and we heat it up, and it could be either equation 1, 2, or 3. Now, these are skeleton equations because they haven't been balanced yet. All right, but we're trying to find out when sodium chlorate decomposes, does it give us NaClO2 and oxygen, NaClO and oxygen, or NaCl and oxygen? What we should be able to do, right, is look at some masses to determine if we have equation 1, 2, or 3. So make sure you read this entire first page and the back. Okay? Then we're going to collect data the following week. So let's look at what we have to do for our pre-lab. The first thing is our purpose. I already told you, you want to make sure that you fill in what's in bold in this introduction. Then you're going to balance the 3 possible equations and include the 6 mole ratios. All right, I graded your 12-1. So if you turned it in on time, I graded your 12-1. So this is 12-1, and this is what mole ratios look like. I'm going to tell you now, and I'm not going to give you these points back if you do this incorrectly. If you give me a mole ratio that looks like this. So maybe I had someone do this. For this one, they wrote 1 Fe2O3 over 3 Na2O. That's not a mole ratio because it doesn't have the word mole in the numerator and the denominator. I will not accept mole ratios that do not have the word mole in them. Okay? So you're going to balance, and then you're going to give me the 6 mole ratios that you get from equation 1. Then you balance 2, give me the 6 there. Equation 3, give me the 6 there. The next thing you're going to do is you're going to find molar masses. All right? You're going to give me the names of NaClO2, NaClO, right? This one's sodium chlorate. Hint would be, right, to look at your polyatomic ion list. And then you're going to give me the molar masses. Now, I'm going to use my review from chapter 10 so that you know what I expect for work here. Here is a review from chapter 10. Here's the name, formula, work. This is what I expect for work. You want to, there was a typo here, so let me just change that. But what you want to do is show how many atoms you multiplied by the molar mass on the periodic table to get the total. And then for your final answer, all of these should go to 1 decimal place. The unit for molar mass is grams per mole, and then you include the substance. So make sure you do that for number 2. Then you're going to go to the back. It says for each reaction, calculate how much solid product would be produced from the decomposition of 1.0 grams of sodium chlorate. So essentially what you're doing is saying, if I have 1.00 grams of sodium chlorate, how much NaClO am I going to make? NaCl. This one should say NaClO3, NaClO2. I just noticed that. So it should say grams of NaClO3. Okay, now here on the back, what you're going to do is assume, it says for each reaction, calculate how much solid product would be produced from the decomposition of 1.00 grams of sodium chlorate, NaClO3. Use the molar masses and balanced equations from the front. So here, we're assuming that for equation 1, we're going to use this mass of 1.00 grams of NaClO3, and we're going to find NaClO2. So what I noticed is you have to put a 2 here. So please make sure you put a 2 here because you're finding grams of NaClO2. Then for equation 2, it's the same reactant, but now you're just going to find NaClO, which is this one. And then the last one, you're going to see how much you would find if it was NaCl, which is over here. So all of these the middle step should be that mole ratio. Okay, so make sure that that's your mole ratio for those three problems. So then a student followed the procedure for the decomposition of sodium chlorate and decomposed 1.00 grams of sodium chlorate. For the product, the student obtained 0.52 grams. Based on this data and the calculations you made in equation 3, what would be the name of the product? So ideally what this student did is they figured it out for each one, right? So let's say this is 1.00, and I'm just going to make up numbers. I'm not saying that this is right. So this is made up data, right? Let's say this one is 0.42, 0.92, 0.50. So I'm just making up these numbers. I'm not saying that these are my right sig figs for these. I'm just saying these are examples, right? So then what if they got 0.52? Based on this, would it be equation 1, 2, or 3, right? For the product, right? So it says here, based on the data and the calculations, what would be the name of the product? Would it be NaClO2, NaClO, or NaCl? All right? And then you have to tell me how you got your answer. So make sure you tell me how you got your answer. So that would be the explaining. I'm looking for some specific words to help us to know why it's the one that you chose. Your answer should say either NaClO2, NaClO, or NaCl, and why. All right? Once again, these were made up numbers. Don't use this. You're going to use the actual numbers that you get from your calculations. For this last one, use a complete sentence and state what observation can be made to determine that the reaction is complete. So I would encourage you to read that first page front and back to figure out how you know that the reaction is complete. So this will be collected the next time I see you.